In this video, we're going to see how to use the TI series calculator for section 8.3, testing a claim about a proportion. Since we're using technology, we're also going to use the p-value method for our tests. Alright, so on the first item here, I've copied and pasted the steps for testing a claim about a population proportion. Alright, so our notation, N is sample size, P hat is the sample proportion, P is the population proportion, and then Q is 1 minus P. The requirements for using this particular test is the sample has to be a simple random sample, 2, they have to fit conditions for a binomial distribution, and 3, we must have at least 5 successes and 5 failures. And then the test statistic down here is a formula that we're actually not going to have to use because the calculator will give us the test statistic for our test. And we're going to use p-value given by the calculator to make our conclusion at the end. Alright, so let me scroll down. This comes from your textbook. This is also done in your textbook using the more traditional method. We have, based on information from the National Cyber Security Alliance, 93% of computer owners believe that they have antivirus programs installed on their computers. In a random sample of 400 scanned computers, it was found that 380 of them, or 95%, actually have antivirus programs. Use the sample data from the scanned computers to test the claim that 93% of computers have antivirus programs. So to make sure our requirements are met, first, does this come from a simple random sample? And it states in the problem that it is a random sample. Are the conditions met for a binomial distribution? The answer to that is yes. We had 4 items that we had to check. One of those is, do we have a set number of trials? Yes, there are 400. Second item on there is, do we have just, are they independent? And yes, each computer scanned the results for one do not affect the other. Do we have just 2 options, success and failure? Answer is yes. They either have an antivirus program or not. And then last, we have a population claim of 93%, so we do have a 93% success rate. Okay. Then, do we have at least 5 successes and 5 failures? So let's check. Out of the 400 scanned computers, 380 of them had antivirus programs, so there are at least 5 for sure, 380. And then that means that 20 of them did not, so that meets at least 5 successes and 5 failures. Alright, next item is to write the null and alternative hypothesis based on the statements in the problem. We have to decide if it's a right-tailed, left-tailed, or two-tailed test. So our null hypothesis is testing the claim, the original claim. So the original claim is that 93%. So our original hypothesis is P is equal to 0.93. And the alternative is whether we think it's greater than, less than, or not equal to. So reading back up here, there isn't a claim that says greater than, even though it was found that 95% did have antivirus programs. They're not saying in here that we're testing to see if it's greater than or less than. So if it's not specifically stated, we're just going to test the claim that it is not equal to. So I'll find the not equal symbol in here, is in the equations. So we're testing the claim that P is not equal to 0.93. Okay, we would use a one-tailed test if they actually specifically asked us to say that more than or less than, then we would use a greater than or a less than. Alright, next item, we identify the significance level if given. We are not given one in here. We're going to use a p-value test, and very commonly a significance level of 0.05 is used. If it's not stated in the problem and it's not a life or death situation, 0.05 is acceptable. Then we're going to run our test using technology. I think you'll really love the calculator after you see this. So on our calculator, let me go ahead and turn it on. This test is called a 1 proportion z test. We're we've got one proportion, we're using a normal distribution, and we're running a hypothesis test. So click on Stat, arrow over to Tests. On this particular calculator, it's option 5. Select option 5, and then what it will ask you for the prompt, it wants the population proportion, the null hypothesis, that's p with a subscript 0. We think that the population proportion is 0.93. They're asking for the x value. The x value is, in our sample, it's the number of computers that had a virus in our sample. So now we're talking about, we put in the population proportion that we're testing against, and now we put in our sample data. There were 380 out of N 400 computers that had the antivirus. Then on the next, notice all three possible tests are here. We're testing that the not equal. Okay. Come down to calculate. Now we're also going to draw. We're going to come back to this menu and draw, but we're going to calculate first. So here's the results of our test. It restates the test. It's a two-tailed in this case, that the population proportion does not equal 0.93. The z value, this is the test statistic. This takes the place, if you were to put the values into the formula, this is what you would get. Z is 1.5677. The p, this is the p value. It's the probability of 0.1169. P hat is the sample proportion of 0.95 or 95%, and it restates N at the bottom. So to show you what we just found, let me go back to the tests. So go back to Stat, over to Tests, back to our same one prop Z, and we still have all of our information in there. I just want you to draw a picture of what we just did. If you click on that, here's what happens. This p-value is 0.1169. The z value that went with our sample is 1.5677. That means if the mean really was 93% right here, 95% was over here, 1.56 standard deviations from the mean. We're using a two-tailed test, so we use the area in the right tail, and we go 1.5677 standard deviations to the left, and we find the area in the left tail. And these two areas added together are that 0.1169. Okay, that means that if we were to get, that it's not that unusual to get 95% of computers if the true population proportion was 93%. So when we have these p-values, they refer to probability that our test statistic is unusual, basically. So if it's not below 0.05, and in this case it wasn't, then it's not unusual. Okay? So our conclusion and our reasoning, the p-value is greater than the significance level of 0.05. This means we failed to reject the null hypothesis. That means our sample wasn't so unusual that it was outside of what we think could happen. And then it's customary to include the p-value in the conclusion when we're using p-values so the reader can make their own conclusion. So our statement, this is our conclusion in just regular language. There's not enough evidence from our sample to suggest that the proportion of computers with antivirus programs is different than the claim of 93%. So notice we say is different, not greater than, not less than. It has to match what test we did. We did a two-tailed with a not equal, so we use different. And then we include our p-value of 0.117. That means there's an 11, it's just not unusual. All right, I do want to show, while we have the calculator here, how you would run this test with a confidence interval. Okay, so I'm going to go back to Stat, over to Tests, and we're going to run a let me find it here, a one prop Z interval. This is what we did in chapter 7.2. And based on our sample, notice I don't have the population in here at all, but based on our sample of 380 out of 400, I'm going to choose a confidence level of 95. Let's see, I had a two-tailed test, right? And so yeah, that would be right. A confidence level of 95% would mean I'd have 5% in between the tails. Okay. If we calculate the confidence interval, it says based on our sample, it estimates the true population proportion at somewhere between 92.8% and 97%. And then when you come back up here, our population proportion, our null hypothesis of 93% is in there. So that also tells us that it's not unusual, because our claim, our null hypothesis of 0.93, is actually in the confidence interval if we were to try to make a confidence interval based on our sample.